Welcome back. So here on problem number 9, we are going to graph each exponential function. We're going to identify the domain, the range, the Y-intercept, the asymptotes for each function. Let's underline those instructions. And then we're going to express that range using an inequality. Okay, so we have some important work to do here. So usually I like to set up a t-table before I even graph it, just because I have an idea maybe. Well, at least it's that way for linears and sometimes for quadratics. But here for exponentials, I really want to see where this graph is going before I even think about writing up a t-table. So let's go into your calculator, Control Doc, New Graph, and recognize this is a negative 2 to the x power. Make sure that you're using a negative and not a subtract. What do you think this negative out in front of the 2 is going to do? We've already seen on the very first page how to flip things right and left. Let's see what's going to happen this time. Aha, so this flipped down. It reflected over the x-axis. If we turned it upright, it would match this one. If we flipped it back over the x-axis, so that kind of makes sense. This is negative 2 to the x power. And so it's heading pretty much in the same right-left direction, but this time it's going down. So that gives me some ideas of where to draw my t-table. And most of my points will be over in the negatives on the left. X, Y, -5, -4, -3, -2, -1, 0, 1, 2, 3. So what does your t-table make? Control Doc. No, sorry, Control T. Control T. And here we are at negative 0.03, negative 0.06, negative 0.012, negative 0.25, negative 0.5, negative 1, negative 2, negative 4, negative 8. So these numbers are very similar to the ones that we had on the first page. They're just all negative because they are all reflected over the x-axis. So 1, 2, 3, 4, 5, down 3 cents. Negative 4, down 6 cents. Negative 3, down 12 cents. Negative 2, down 25 cents. Negative 1, down 50 cents. 0, down a full $1. And now things will start making real numbers that we understand. So here's your curve. That was pretty great. That was pretty easy. So let's discuss your domain and range, Y-intercept, and asymptote. So the domain. how far does this graph travel left and right? Does it ever stop going to the left? No, it keeps going. Does it ever really stop going to the right? No, that keeps going. So this is all real numbers. Now the range. And we were told in our instructions that the range was wanted in the form of an inequality. So this inequality is always about y and where we topped off at. Well, we topped off at a value of 0 because it's the x-axis. The question is, could we ever be equal to 0? Did we ever see 0 on the y column of your t-table? No, we got really, really close to it, but we never got there. So since we never got there, there will not be a bar here in my inequality. And then my curve is below y equals 0. So everything is smaller, it is less than. That is my range. Everything is underneath y equals 0, but not equal to, so there's no bar there. The y-intercept happens at the point 0, -1. All right. And then finally, the asymptote. It is this relationship here, but with the equal sign in the middle. Y equals 0. That's the value that we could not touch. That's the value that could never, ever happen. So I want you to pause the video, and I want you to try and do number 10. Let me know if you need a little help. Let's do number 11 together. An investment of $2,000 is in a bank and it doubles every year. Ooh, I like it. We need to write a function rule that will model the value of the investment. If the investor does not withdraw any money from the investment, when will the value of the investment first become more than $15,000? Okay. So if you look at the very beginning, the front page of this, we said A is your initial value. It's also your y-intercept. B is what it's doing. That's what we're multiplying to A. Okay. So y equals A times B to the x. A is my start. It's my initial. So what is A in this problem? How much did he have to invest? $2,000. That's right. B is what it is doing. So what is B doing in this problem? It's doubling. So when you double something, what are you multiplying by? 2. You multiply by 2. So your equation becomes y equals 2,000 times 2 to the x power. That is your equation. All right. So let's go find out. We want to create more than $15,000. Let's see how long that's going to take to happen. So 1 year, 2 years, 3 years, 4 years. Let's see what we get. Got your calculator handy? Control Doc. We have a graph. 2,000 times 2 caret x. It's way over there, but that's okay. I don't really care about the graph. What I need is the t-table. So Control T, that's what I need, is those numbers. So after 1 year of investment, how much money does he have? 4,000, and then 2 years, and then 3 years, and then I want this investment, but that means I'd have to have $2,000 to do that with. That's another topic. Okay, so we wanted to make what happen? More than 15,000. How many years? There it is. 3 years. And you're done. Nice job. This is how your investments for retirement and things like that work. Although, I don't know if you're going to find one with that kind of interest. All right, see if you can do number 12. If you need any help, let me know.